Hello! Let's learn about basic servo drive setup and trial operation using Drive CM. Drive CM is a software that can be connected directly to the servo drive to set parameters, test operation, etc. Drive CM can be installed together by installing the PLC software XG5000, and it can be downloaded and installed separately from the LS Electric website. The Drive CM is accessible from the PC using a 5-pin USB mini cable. It is recommended to disconnect EtherCAT communication with the controller and connect to the servo drive using a 5-pin USB mini cable. Of course, it is possible to connect the Drive CM during EtherCAT communication, but commands from the controller may cause difficulties in smooth test progress with the Drive CM. Now, let's open the Drive CM and take a look at it together. Drive CM initial screen. First, you can change the language. Once you select language in Setup, you can select 3 languages: Korean, English, and Chinese. If you change the language, you will have to restart Drive CM. Next, I'll try to connect. Select the servo drive you want to connect to. If you click the Offline to Online button, you will see the drive information on the left, and if the USB connected blinks on the bottom left, the Drive CM has successfully connected to the servo drive. Next, we will proceed with setting the servo parameters. Because the servo drive reads information from the servo motor's encoder via serial communication, default settings are not required to rotate the servo motor basically. However, additional parameter settings, such as setting the rotation direction or using the absolute feature, can be followed by the instructions in the Setup wizard, or you can change the parameters in the Object Dictionary. Let's set up servo parameters through the Setup wizard. In the Setup wizard, you can set the main parameters in order according to the Drive CM instructions. When you click Online, the servo drive is automatically selected and the information is displayed on the right. Then press Next. If motor selection is set automatically, motor ID, encoder type, and resolution are automatically set with the connected motor information. Then, press Next. You can set the motor rotation direction and set the gear ratio. In case of emergency stop, you can set related parameters and dynamic brake control mode, and in case of vertical load, you can set the brake signal related to use. By providing settings related to the torque limit function, you can limit the amount of torque to prevent load and motor damage during operation. If the mode of the servo drive is position control mode or speed control mode, provide relevant parameter setting information respectively. The parameters related to digital input, output, and analog can also be easily set. Finally, after setting the parameters related to the homing, click Write to Drive to save the parameters to the servo drive EEPROM. Finally, there are parameters that apply after the servo drive is reset, so you must reset the servo drive after this process. You can also press the Save to File button to save those parameters to your PC. The extension name is CFG. which can be loaded and used in the Setup wizard. Alternatively, you can change parameters directly without going through the Setup wizard. You can also set the settings by clicking the drive-specific parameters in the Object Dictionary or by clicking the book-shaped icon. A total of 9 items are provided, from Basic, Gain, to CIA 402. If you change parameters in the Setup wizard previously, you can also check here. If you change the parameter value, you must enter the value and press Enter to input the value normally. After that, click the Parameter Save to Memory button in the Object Dictionary, or click the memory-shaped icon to save it to the EEPROM in the Servo drive. You can reset the Servo drive by clicking the Software Reset button among the icons, because there are parameters that must be reset as needed. On the other hand, there are parameters that cannot be set when the servo is in the servo on state, so it is recommended to change the parameters in servo off except for tuning-related parameters. Servo drives provide 20-pin or 50-pin maps depending on the product. The I/O tab of Drive CM allows you to select the input/output of the servo drive. You can check the on/off status of the input/output parameters of each servo drive and change the assignment information for each pin. It can also be changed to A high or B low, depending on the sensor type. For example, when a POT, an upper limit sensor, in the form of a normally open, is detected, the contact status can be checked in real time. If you change parameters, press Save to Memory to save them to the Servo Drive EEPROM. If you change parameters on the I/O tab, this information can be viewed as the same as changing the I/O parameters of the drive-specific parameters. On the Fault tab of Drive CM, you can view the fault configuration, alarm history, and alarm list. Fault configuration allow you to change and set the occurrence conditions for alarms and alerts. In the alarm history, you can check the alarm history of up to 16 alarms, which means the most recent alarm that occurred from number 1. The alarm list contains each alarm code and check details. Click the Fault Reset button to reset all alarms. Drive CM provides optimized diagnosis or monitoring to the customer. First, you can click Trace Trigger Monitor to see the screen. A total of 4 channels can be monitored at once. Select the item you want to monitor for each channel. I will select Velocity Feedback, Velocity Command, Torque Feedback, and Following Error as examples. And if you click Start, you can monitor each item in the form of a graph, as shown on the screen. In this case, you can monitor the items of 4 channels on one screen by clicking Single Grid. You can adjust the sampling time or the entire time of the x-axis by selecting the x-axis tab. After stopping the graph by pressing Stop, You can zoom in and out using the mouse wheel. And you can check the graph in detail using zoom and pan buttons. If you activate the cursor and check the Cursor Measurement tab, you can check the number you want to measure for each channel. Meanwhile, in the gain window, you can tune the gain value in real time. If you change the value, press Enter, and after tuning, press the Save to Memory button to save the final tuning value to the Servo EEPROM. In the Cyclic monitor, you can check the status and information of Servo in real time. You can check the velocity, position, torque, overload, encoder, servo general information in real time. You can also set the items to be displayed in the 7-segment window of the servo drive. Before controlling the servo drive in the upper controller, the servo motor can be driven using the drive CM. Let's do the most basic jog operation. Click the Manual Jog button. You can see the Manual Jog window on the right. Before jog operation, let's start the Trace Trigger graph first. Select Velocity Feedback, Velocity Command, Position Actual Value, and Position Demand Value to start monitoring. First, click Drive On to Servo On. Set the speed as stable as possible. Then enter 10 RPM and press Enter. The acceleration and deceleration time is set to 1 second at first. Then press positive for forward. During pressing the button, the servo rotates forward. Press negative to check the reverse direction as well. If there is no big problem, you can check the status of the system by increasing the speed slightly. Check the servo and mechanisms again by rotating at 60 RPM, that is 1 revolution per second by the motor. When operating is finished, press the Drive Off button to turn the servo off. In the case of using EtherCAT servo, IX7NH, L7NH, and Pegasus, you can set the homing parameters on the servo drive. First, click the homing button. On the right, you can see the homing window. Select the homing method. The homing method is specified by numbers, and the actions each number means are also provided in the time chart below. And the homing method can be set in the manual for the reporting system. In this example, we will use the 28th method, which is the method of returning to the origin while driving in the reverse direction using the home sensor. Enter the switch search velocity, the marker search velocity, and the acceleration. Switch search velocity means the high speed of returning to the origin. And marker search velocity means the speed that moves to find the correct position after sensing the home sensor, etc. The unit of speed is shown as user units per second. And UU is short for the user unit, which means the speed in pulse unit applied up to the electronic gear ratio. In other words, if the switch search velocity is set to 524,288 user units per second, it rotates at the speed of 1 revolution per second based on the motor of 19 bits. The unit of homing acceleration is user units per second squared. Since it is acceleration, not a time, the speed divided by the acceleration becomes the acceleration time or deceleration time with seconds unit. Before we start the test, we will monitor trace trigger monitor. We will monitor 3 channels: velocity feedback, position actual value, and home. For the homing operation, servo on is done by clicking drive on, and I will click homing button to start the homing operation. After homing is completed, you can see that the current position is 0. You can use the Drive CM to position move. If you select PTP Move, you can see the PTP Move window on the right. First, you can select 2 operation modes. In this video, we will test by selecting Absolute Move. If repeated operation is selected, the round trip between target position 1 and target position 2 is performed. For example, we will rotate the motor 10 times from an origin position. At this time, we will set the velocity to 5 rotations per second and the 500 milliseconds for acceleration and deceleration time. First, press drive on to servo on. To specify the target position, you must specify the absolute position. After adjusting the position of the mechanical parts with the jog button, enter 0 in the set position and press the set button to change the current position to 0. Since the previous speed was designated as 5 revolutions per second, I will set it to 2,621,440 user units per second. In order to make the acceleration-deceleration time 0.5 seconds, I will input the acceleration-deceleration as 5,242,880 user units per second squared. Next, enter the target position 2. If it is 10 revolutions, you must enter 5,242,880. Dwell time is the time to wait for each target position to start again, and I will designate it as 1 second. After specifying the items for each channel to check the operation, press Start to monitor the graph. After that, when I click the Move button, the servo repeatedly operates the target position 1 and target position 2. After that, press Stop to stop the motor and press Drive Off to servo off. The servo system provides a tuning function that optimizes the characteristics of the motor according to the load. Tuning is largely divided into manual tuning and auto tuning. Manual tuning is for the user to adjust the tuning value himself. Before performing manual tuning, we will run PTP Move. Then press Start on the Trace Trigger monitor screen to start monitoring. Next, press Gain window to display the tuning item window. In real time, the user can modify and reflect the desired tuning item. For example, if you want to increase the inertia ratio, change the number and press Enter to apply it. After finding the optimal tuning value, save the final tuning value in the EEPROM in the Servo drive with the Save to Memory button. Meanwhile, Drive CM offers auto-tuning. Click Auto-tuning in the procedure. You can see the auto-tuning window on the right. Auto-tuning provides two methods: offline tuning and online tuning. For offline tuning, set the rigidity for tuning, tuning direction, and tuning distance, and press the Tuning button to find the tuning value after 3 repetitions. After that, perform user fine manual tuning to find the optimal value. Click Save to Memory and save it to the EEPROM in the Servo drive. Also, if you check Online Tuning, you will find and apply the tuning value in real time. Depending on the rigidity, online tuning is conducted by referring to the value of the gain table in 20 stages, and the tuning result is periodically reflected, and the changed gain is saved in the EEPROM about every 2 minutes. Thank you.